Hi, welcome back everyone. Now what I'm going to do is, instead of doing the whole stock and flow diagram and then doing the model, what I'm going to do is just do little parts of the stock and flow diagram and then do little parts of the model so you understand some of the smaller ways that things are modeled, or the smaller bits of a model. So, alright, so this is back to our causal loop diagram, and then we'll do stock and flow diagram. What I've done is I've labeled everything product. So what we're going to do is play whack-a-mole between fixing product issues and fixing service issues. So those are the two circles. Okay, so we have product results. Our performance on product might be functionality, quality, share in the market, things like that. The gap to our goal. The larger the gap drives management time over here, time, resources, money, talent, things like that. And that more time here would drive better product results. So that's the balancing loop. So now we'll do a stock and flow diagram here. So the first question we need to answer is, what is the stock? So every loop will have one stock at least, so that the loop is not instantaneous. So one way to think about what the stock is it's something you can count: number of employees, money in the bank, number of products, number of customers, things like that. Results, there's not really that obvious concept of something you can count. Second question I ask is, what did you graph here? Because a lot of times what you graphed, the main result is usually a stock. So we graphed the result. So the result eroding, and then improving, eroding, then improving. So product results is a good guess. And then the other thing you think about is what changes instantaneously, or can change nearly instantaneously, and what takes time to change. So product result driving a gap relative to a goal. If the result changes, the gap changes. That's instantaneous. So that's probably not a stock. The gap is not a stock. If there is a big gap and management wants to move toward it and pay attention to it, that's relatively instantaneous. So certainly time can be done quickly. Resources and money might be a little bit more slowly. So that's a potential. And then spending time on the product, resources on the product, does that take time to yield results? The answer is yes. So there's definitely a delay with results. So results seems to be the likely candidate for a stock. So we'll model it that way. So stock goes in a box, product results. Now the question is there an inflow? Do results improve? Sure. The management time on the product is designed to improve the results. And do results erode? What we're going to do in our model, similar to the game Whac-a-Mole, is if you ignore something, then the results will erode naturally. So if you go over to fix something else, then these things will erode. So there is a flow out. So what we're going to do now is we're just going to model the flow out for a sec. So product results left by themselves erode. That's what we're saying. So there's a flow out, product results eroding. And then a very popular flow is just a percent. So you have an erosion rate. So maybe let's say your results erode 10% a year or 10% a quarter by themselves if nobody's paying attention to them. So we have product erosion rate. Okay, so it'll be some percentage. That multiplied by the product results. So here are the results, here's the erosion rate for a particular time, and that makes it erode. So that's a very popular kind of formulation of something that erodes at a percentage over a fixed period of time. So what we're going to do now is we're going to head over to Excel, and we'll just model this little piece of the stock and flow diagram, and then we'll come back. Okay. Now we're in Excel, and we're going to create this simple model in Excel, and this is
an important model component that you'll use often, which is draining from a stock with an erosion rate. So we always start our models, first of all, I always paste my model down here so I can see it. We always start our models with any constants. So a constant you can find by there's no arrow coming into it. So product erosion rate is our constant. It's not affected by anything. So product erosion rate, and we will do 20% per year. How about? I always type in the time dimension so I don't get confused with units later on. Now we'll do the model part. That's the only constant. So we start with time. We have a 0 column to get a few things set up, but then we have a real model, which is the left plus 1. Now we have our stocks. So I always do stocks with a beginning, product result, and an ending. And we'll say this is, let's say our product results are on a scale of kind of 1 to 100. And that might be a customer satisfaction score or, you know, I don't know, percent quality or something like that. So we'll say it's at 80, which is pretty good score, but not perfect. In time 0, the beginning and the ending are the same. And then in time 1 and everything after, the beginning is the same as the ending from the period before. Now we'll do our flow out. So this is product eroding. And the way the flow is calculated is it's the beginning product result times the erosion rate. And we'll do time in months. So I'm going to divide that by 12. Mark that time in months. Product erosion, that's good. I will take off the decimals. And then the ending product result is the beginning minus the erosion is the ending. So let me just cut that one more time, make sure it looks good. Nope, doesn't look good. So I forgot to name my constant. So if you give it a cell range, the cutting and pasting will work out much better. So I'm going to redo this formula. Instead of B1, and repaste it. And we'll give it the cell name. And then cutting and pasting works out much better. Okay, let me take off the zeros there so it looks prettier. Okay, now we are good. Actually, I needed to take off. Yeah, that's all right. No worries. Now we'll cut and paste the model. I'll do 50 of these things, which I think of 50 as 2 alphabets. BZ, it was 4 rows long. Okay, so that's our model. And now I'll graph the product results. Where are my graphs? This is a new version of Excel for me. Insert line. That looks good. Oops, that didn't look good. Insert line. Do 2D line. There we go. Okay, so that's kind of what you'd expect. You see it starts at 80, and you see it erodes, and I'll explain on the board. It kind of slows down in its erosion, and it's heading toward 0. Okay, so I'll go back to the board. We can talk about this for a few minutes, and then we'll close.
Great, so I hope that was helpful. So what we saw is when, I just want to draw a behavior over time diagram. So we saw when there's kind of a percent erosion rate, which is a popular formulation for something that's draining. It's like a bathtub here draining its water. What the shape of that curve looks like when you have that is like this. Okay? So it's goal-seeking in that it erodes down to 0 because there's no inflows. The erosion slows down in a sense. So if you have a fixed erosion rate, like in this case, times an ever-decreasing stock, then it will slow down. and then eventually it'll hit 0. And the other thing that's true about something like this is it has a half-life. So these results will be cut in half in a fixed period of time. And you can calculate that by, it's actually roughly 7 over the erosion rate. So, so if the erosion rate is 10%, it'll take 7 years to cut in half, then 7 years to cut in half again, 7 years to cut in half again. So that's the way this kind of drain actually works. Okay, so I'm going to close this, and then we'll do the other part of the stock and flow diagram next.